Okay, all right. So let's look at the definition one more time. Okay, a function is a rule. So whatever we call is a function is actually a rule, right? A function is a rule. What does this rule do, right? So that after the rule enters the specifics, a description of what kind of rule will be qualified, what kind of rule will be qualified as function. Okay, so this rule takes each input from domain and produces how many output in the range? How many?
One.
One?
Exactly one.
Exactly one. If you say one, wrong. The word exactly one must be there because exactly one emphasizes the uniqueness. Emphasize the uniqueness. Okay, and then you see this definition is so abstract. This definition is so abstract. When I'm going to use it? When I'm going to use it? Okay, so right now, what I like you guys to do is that everybody is in front of a computer, right? I want you to go to Google and find a stock market curve arbitrarily, okay? Whichever field you're interested in, if you're interested in real estate, you find a real estate curve. And if you're interested in any specific stock, you find that curve. And you pick up any curve like that, and you take a look at it. How is this definition related to that curve? Okay, so I'm gonna take, well, I know you guys are gonna see a variety of them, okay? So I'm just gonna pick one example from my Google. Let's see if I can, you know what? I'm gonna share that screen with you, okay? You pick yours, you look at yours, okay? And I'm gonna show my pick. Okay, I just pick one randomly. I really just pick one randomly. Okay, there you go. Do you see this curve?
Yes.
Okay, so and here we have a couple curves, right? We have a couple curves. There's a blue curve and there's a green curve. Okay, and I'm gonna make a claim. I said this blue curve is a function. This green curve is another function. Okay, am I right? Now the question is, what is the input? What is the output? The input on the graph, can be found by drawing a vertical line. You guys see that? A vertical line. This vertical line will hit this horizontal whatever. Usually it's year, okay? Maybe 2018, another one maybe 2019 and so on and so forth. Suppose this dot is 2018. Suppose this dot is 2018, okay? I'm just making some assumptions, okay? Because I want to show you what is the input and what is the output. What is the input, what is the output? And how do we read the chart? and why this definition is so important and it is so useful. When you're in calculus, you start with function. So you must know what function is. You must know what function is. What is function? Function is defined as such, So now you look at this dot. Suppose this dot is 2018. I'm just making up numbers, okay? I'm just making up numbers. My point is 2018 is what? Is the input. And you see 2018 is the input. Well, that's a very simplistic input. Okay, the year is the input. Okay, the year is the input. And what is the output? What is the output? For the blue curve, what is the output?
The y-axis?
Horizontal line?
It's the vertical line. The price of that stock. You guys follow me?
Yep.
This height from the blue, you see, I draw this vertical line. It hit the blue curve, right? And there's a crossing. There's a crossing. At this crossing, it indicates the year and the price. And what is the price? This is the price. What is the price? How high this is the price. And you, of course, you're gonna read the number right here, right? You're gonna read the number right here. Do you guys see me? Do you guys hear me? What is 2018? 2018 is a measure, is a year. Is a measure from the year when Jesus was born. That's 2018. That's a timeline. So it's in that direction. So the horizontal indicating is indicating the input, and the output is the vertical height. Do you guys follow me? Okay, so let's draw another one. Someone messaged me about, of course we have class today. Jeff. Hold on, just 1 second. Someone is anxious. Are you guys in? All right. Okay, everybody's in? Okay. So let's do another curve, right? I want to show you how this is the definition. Okay. For the input 2018, how many output out there? 2? How many output? For this year. Okay, for this year. Okay, the year is measured from how is the year measured? Measured from, you know, the year when Jesus was born. Okay, why do I get this message? Excuse me, okay, someone is click. Sorry about that. I don't see you in the waiting room. Oh, there. There, got it. Sorry, got it. Gotcha. All right. There we go. Okay. All right, guys. So let's continue to study this, okay?
Professor,
Yeah,
I have a question.
yes.
So the output is the vertical pink line, right?
The vertical, no, that's not a pink line. That's too high. Okay. Let me show you again. Okay. The input is 2018, which is a year, right?
Mm.
The output is the red.
Okay.
Is that clear?
Yes.
How high? Okay, how high? Maybe I should change the picture. Do you guys see this height had the same scale as these, right? So if you try to see how high is this is probably half of 10 million, right? So if you mark this point, let's how mark this point. This point is 2018, comma, 5 million. You guys see that? The first number is the input, the second number is output. Do you guys see that? So for this input, how many output are there? How many output are there?
Exactly one.
Exactly one. So among all the stock market curves you have you found any picture, any curve that has two output for a input? Have you found such a curve?
No.
I'm sure you haven't. Okay, I'm sure you haven't. Okay, at any given moment on that curve, there's only one price. Yeah, does that make sense?
Yeah.
Is that a function? It's a function. So that's what I'm saying. This blue curve is a function. The green curve is a function. How do we judge it? Definitional function. The only thing is that the only thing that we don't know is we don't know what's going to happen tomorrow. Okay, suppose we're standing at the point today. Okay, suppose we're here. Suppose we're here, that's today. We know the price today. Do we know the price tomorrow? We don't know. That's why people get so excited about what's going to happen tomorrow. It's always the case. Humanity is a forever struggle to figure out what's going to happen tomorrow. Okay? So do you guys understand what I'm saying here? So this definition is real. It's real. Okay? All right. So do you have a curve you want to share with me? Share with us? No? Okay. Good morning. Is everybody in? I'm sorry. Okay, do we ignore the other green line? Oh, no, we don't need to ignore the other green line. So yeah, we can look at the green line. Okay, so let's look at the green line. Of course, the green line is a different function. Okay, the green line is a different function because because typically you will see the legend and the blue represents something, the green represents something, right? The green represents something, the blue represents something. So let's work on the green one. Shall we? I'm going to get a dot right here. Okay. So what about this point? To find the input, we draw a vertical line. Okay, I'm going to change the color. Okay, I'm going to change the color. This, hold on, because I need the red one. Okay. I'm going to use this color. So I'm drawing a vertical line. This vertical line crosses the year. So suppose this is 2020. Okay, suppose this point is 2020. Okay, so that is 2020, last year. Okay, and what is the output? What is the output, you say? The output is this height. Hold on. Okay, the output is this height. From this dot, this line is this height. So the input, okay, the input is measured from the year when Jesus was born all the way to 2020. And the height is the output. So this is the input and that's the output. You guys follow me? So this dot of star, how do we mark it? How do we mark it? 2020, and there's a number, right? So let's use that number, which is 100 million. Input, output. Do you guys see that? Does this process look familiar?
Yeah.
Did you learn this in algebra? Have you learned this? Have you learned something similar in algebra?
Yeah.
Points, right? Points. So what are points? What are points? This number is the input and this other number is the output. Okay, so this number is the input, this number is the output. So I'm going to mark it here. And that other number is the output. And in your algebra class, what does it call? What does it call? How do you call it?
X and Y.
X comma Y. And that's the mathematical abstraction. This is the mathematical abstraction. But if you take this mathematical abstraction and you apply to stock market, that's how you read it. Do you follow me? Okay. Any questions so far? Do you think this definition is abstract? Is still abstract? Is it still weird anymore? Do you still think this definition is very weird? Okay. It's actually pretty simple, right? So we have an input and we have an output and we pair these two numbers together and we make the graph. That's what we do. And it's very commonly done in today's world, in data science, right? You guys heard about data science. large quantity of data. What do? They process these numbers. Okay, and of course, this is simplest form of the numbers. Okay, because if you think about the input by year, it's actually a very simplistic way, because that year there's a lot of happenings. The output has a lot to do with the happenings. So the year is just a simple way to indicate the input. Okay, it didn't mention, you know, in 2020, we had pandemics, we have all these things happening, which causes the output to be such. Do you follow me? It's a simplistic way, it's an abstraction. It's an abstraction. It's a simple way of presenting the data. All right, without further ado, I'm going to you know, clear all of these, and we're going to come back. Okay, and I'm going to bring back our function. We'll come back to this definition. Okay, so now we're going to look at basic one. Each one of those functions in basic one is a function. And let's see what it means. Okay, so in this class, it's very important you understand the meaning and you understand what we're talking about. Okay, so we talk about grammar, right? What are the two kind of sentences we have in mathematics we talked about yesterday? How many different type of sentences do we have in mathematics? Two. What are they?
Statement and an if
Statement or if statement. Two. No more. I promise you. Even when one day you go to graduate school, a PhD student in mathematics, the kind of sentences you're dealing with, two. Okay, if you deal with a third kind of sentences, you better come back to tell me. Okay, because I like to know. And in the future, a lot of you is going to learn programming, right? That's where you're heading, right? Guess what kind of sentences you're going to see in computer science, in computer programming?
Statements.
Statements? If statements. The if statement can get very complicated. They can loop. They have branches, but if statement. Two kinds. Any one of you have some programming experience? Would you like to share that with us? Am I right?
Yeah, it's hard.
It's hard, but you only have two kinds of sentences. It makes it simple to read. And of course, you have to understand what's going on. Okay, so now, function. The first such example I want you guys to look at in your notes is a constant function. Okay, so I'm gonna, do you guys look at basic one? What is the first function? What is the first function? F of x equals c, right? Yeah?
Yes.
The first function. Okay, f of x equals to c. What does it mean? What does it mean? Okay. C is for constant. Let me just move. I just need to adjust the. Okay, make some adjustment to the file. Okay. C is a constant. C is the first letter of constant. Okay, see the first letter of constant, so the shorthand notation. So then you say, what is C? C could be any number. Okay, so let's give an example. Let's give an example. Suppose I choose the constant equals to 2. 2 is a constant. F of x equals to 2. What does it mean? If you look at the function definition, if you look from the function definition, what does it mean? It means you give me an input, the output is always going to be 2. That's what it means. Okay, so this rule, okay, this rule says you give me an input and the output is 2. You give me any input, the output is going to be 2. Okay, for example, if you give me the input of 0, the output is going to be 2. If you give me the input of 0.5, the output is going to be 2. If you give me the input of 12, the output is going to be 2. No matter what is the input, the output is 2. So what are the numbers that are qualified to be the input? Tell me. Because that's the rule. This is the rule. So this description is the rule. Okay? This is description of a rule. Do you guys get it? Then if this is the rule, what are the numbers that are fitting to be the input?
It can be any number, right?
That's right. It can be any number. And there we go. We got the domain. So under this rule, okay, all possible input make the domain. Okay, so you look at the rule, you see, you look at the rule and then you ask the question, and this question is natural, right? If I know the rule, what are the numbers will be fitting to be the input? And there we go, because for every input, there has to be a unique output. Is 2 unique? Of course, 2 is unique, right? Okay, so that's the domain. And what's the range? So in this case, it's all real numbers. So what is the range?
2.
Would the range be 2?
That's right. There's only one number in the range. Okay, so the range is a number, we're going to put it in a curly brackets, in a curly brackets, because in the range there's only one number. For every input, there's an output. Every input, there's an output. If we run through all possible real numbers, what kind of pair of numbers can we get? If we pair up the input with output, right? Just like we did with the stock market graph, right? So what kind of point are we getting? What kind of point are we getting? If 0 is the input, output is 2. 0.5 is the input, the output is 2. 10 is the input, the output is 2. Right? 100 is the input, the output is 2. -3, the output is 2. What happens if you plot all these points in a rectangular system? What do you get? What are we getting? Are you guys plotting?
A line,
What kind of line?
horizontal.
Perfect. That's a great answer. That's it. Right? So what do we see? So this function, okay, if you graphed it, it's a horizontal line. Okay, and how do we read this graph? How do we read this graph? How do we read this graph? The same way we read the stock market line. Okay, so if I have a dot, if I have a point, okay, how do I identify the input and output? You draw a vertical line, okay, and you measure. This is the X, this is the X, this is the input. And what is the output? What is the output?
2.
The output is 2. How long is this? It looks like it's 2.5, right? 2.5. And the output is what? 2. For every input, every dot you have, for every dot, input, all of these input, for each one of them, the output is what? The same, 2. Okay? The output is 2. That's the meaning of this function. And for every input, how many output are there? I want to hear it.
Exactly 1.
Exactly 1. Exactly 1. Very good answer. Okay, so now let's move on to the next curve, next function. What is the next one? What is the next one? What's the next one in the table?
Y equals X.
F of X equals to what? 1 over X. What kind of rule is this? If we go by the function criteria, what kind of rule is this? What kind of rule is this? The output is what? F of X is equals to 1 over X. So the input is given to the function and the rule produces what? The reciprocal of the input. Right? So let's practice with this. Suppose I give you input 1. Okay, input 1. Input X equals 1. Goes through this machine, what do I get?
1.
I get 1 over 1. And of course it's 1. You're absolutely right. Okay, so f of 1 is 1 over 1, and that's equals to 1. You see how that rule works? Okay. So if I pair the input output together, what do I get? Input 1, output 1. Another input. And this time I'm going to give the input of 2. And what do we get as the output?
1/2.
1/2. So when input is 2, the output is what? Half. And we can keep going. Can we keep going? Because this time we're going to figure out, understanding the rule. Okay. Then the next question is, what are all the possible input? Because all the possible input make the domain. So if you keep going, you keep thinking. So what are the numbers? That are fitting to be the input and produces, and for each, I'm quoting the definition of function, for each number, right? It has exactly 1 output. Because that's dictated by function definition. So can you tell me what are all these numbers that are fitting to be in the domain?
All real numbers except for 0.
Perfect. That's the right answer. X cannot be 0. This is a shorthand notation. What it means. That's just exactly what you said. Okay, we write X is not equal to 0. It means all real numbers except 0. So this is another rule. And this rule produces what? Produces points. Input, output, input, output. Can you guys graph this curve?
Yes.
Can you guys graph this curve? Please graph this curve. Input, output, input, output together. Okay. Input 1, output 1, input, output. Done that. Okay. I want you guys to complete this table right now and reflecting on the input, output, and then we're going to put the points together. Okay, I'm going to give you the input. Now you complete the table, please. I just give you some random numbers. Is everybody doing it? You must do it. Okay, this is a very important function. This is very important. I know you have learned it before, but I want to remind you how the graph has come about. This graph has come about the same way any function you have learned before. Okay, we're doing some groundwork. These groundwork will help you. Okay, this is a very, very important function. This is very, very important function. You will find yourself using this function when you're in calculus 2. Okay, and of course you're going to use it in calculus 1. Input, output. And we put all of these points together, guess what we get? Okay, so now I want you guys to have paper, pencil with you and plot all of these points. And plot all of these points. Okay, are you guys doing that? I'm doing that along with you. Okay. I want you guys to plot points. Okay, we're plotting these dots. Okay, I'm gonna make some adjustment. You guys know what to do you? Do you guys know what to do? I'm gonna show you what to do. Plotting the points. Okay, so this is a 1, 1, -1, -1. Okay, those points. And I want you guys to plot all of these points in the graph. One half. I want you to plot those points. You guys know what to do. Everyone must be working on your paper pencil. Very good. I see you guys are working on it. You should get something like this. Tell me, is it easy or not?
Yeah, it's easy.
Very easy, isn't it? But once you do it by your hands, it will do some miracle will happen to you. If you go through these steps for each one of these functions and being aware of input output. You see, I don't use XY anymore. Do you notice? I don't use XY anymore. Input output, because this semester, okay, I want to plant the concept of function in your head. Can you knock your head? Do you have the function planted in your head now? I want to plant the function in your head. Function is a rule. And the graph is what? Is the input, comma, output. Okay, so now is it time to connect the dots? Isn't that easy? Domain, we just talked about domain. How about range? How about range? How about range?
All real numbers except for 0.
Very good. All real numbers except 0. Okay, because all you have to see is that you can see the domain can be any real number but 0. And as a matter of fact, you probably have learned before. Okay, these are what? This is called a vertical asymptote, right? Did you guys learn that word before?
Yes.
Asymptote. And there's another asymptote, which is a horizontal asymptote. What does this horizontal asymptote tell us? The curve will never touch them. The curve will never touch them. And therefore, the output will never be 0. But it can be any other number. It can be any other number. Got it? So the range, so what is the range now? Someone just said it. The answer was right. Yeah? So we talk about domain. Where is the domain? Right? And the range. Okay? I'm going to give you a different ways of expressing range. Okay? You can, in your olden days, you probably say y is not 0. Right? All real numbers except 0. That's how you can say it. That's the old way of saying it. Now I want you to adopt a new way to say it. Okay? This is a new way I want to learn to say it. So you mention the rule and you tell the reader that the output will never be 0. The range is a consequence of domain. The range is a consequence of domain. Now we have done 2 functions, but we didn't cover 2 other things. One is the X-intercept, one is Y-intercept, right? We haven't covered the intercept. Do you guys understand what's the intercept? Do we understand what's the X-intercept, what's Y-intercept? Go back to this function. What is the intercepts? What are the intercepts?
Y equals 2.
What are X-intercept? Y-intercept. First of all, what is the meaning? X-intercept is where the curve crosses x-axis. Where does this line, the constant function, crosses x-axis?
It doesn't.
All of them?
All of them?
Yeah, doesn't it?
Does this line, which is y equals to 2, f of x equals to 2, does it cross x-axis?
No.
Nah.
No, never. Right? So none. Right? There's no crossing. It's parallel with x-axis. When does it cross y-axis? That's the y-intercept. Where does it cross y-axis? Where is it? Right here. And that point we're talking about is a description of this point. And what is it?
Y-intercept.
How do you describe that point, that star?
0, 2.
0, 2. What does it mean? When input is 0, the output is 2. And therefore the y-intercept is what? The y-intercept is what? 0, 2. You got it? So now we have all the questions answered. Of course, we have another important question. Okay, we'll come back to. Okay, so let's look at the other function. The function we just talked about. Right? We discussed domain, we discussed the range, we have the graph. So now can you tell me what is the x-intercept, y-intercept?
Zero for both.
0 for both? How does that intercept should look like? There are 2 numbers, there are a pair of numbers. One is the input, the other one is output. Input, output. And what are x-intercepts? X-intercept is where the curve crosses x-axis. That's called x-intercept, right? Where does the curve crosses x-axis?
It doesn't.
Never.
It doesn't. It never touched there. By the way, the curve never touch x-axis. Do you guys see that? So what do you say about x-intercept?
There is none.
None. Do you Do you see any? Do you see the curve across the x-axis anywhere? Is there a crossing with x-axis? Yeah? Is it a crossing?
No.
No.
Did you see the crossing? Please tell me. No crossing. Does the curve cross y-axis?
No.
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 No. None. The next question. The next question. Okay. The next question you will see at the bottom. Okay. If you guys will take it, we'll flip the pages to page number 6 and 7. Okay, number 6 and 7. At the bottom of those pages, I put a function with domain is called a one-to-one function. And there's a specific definition. Okay, this definition was also given on the second page. Okay, so we have covered 2 functions, but I have an important question to ask you guys. Okay, we have an important question. I have an important question to ask you guys. Okay, so we just talked about function, right? I want you guys to read the definition of function for me. Okay, we're reflecting on these definitions. And we introduce another concept called a one-to-one function. We are very much focused on the words. Did you guys notice I'm trying to get you guys to focus on the words? Okay, could you guys read the definition of function one more time? A function is a rule that assigns to each element x in the domain exactly one output in the range. So I changed the wording a little bit, right? I changed the wording a little bit. A function is a rule that assigns each input exactly one output. Can we see that? Now we have another definition called one-to-one function. One-to-one function. Okay, you see these 2 places, you saw those definitions, right? And I want you guys to go back to page number 2 in the notes. The second definition on page number 2. Would you please go there, please? And I want you to write it down, that definition, on another flashcard. What's the definition? I'm basically showing you and teaching you how you're going to handle Math 190. In Math 190, you have lots of these stuff, much more than this. Okay? You have lots of theorems, definitions to deal with. In this semester, you only deal with, maybe 5 or 6 definitions. But in calculus classes, you're going to deal with many, many more. And you have to deal with the way I just teach you how to. If you can't, if you don't do this, you're not going to make it. Okay? I'm saying this in all seriousness. So now write down the definition of one-to-one function. How do we read this? So first we have the definition of function. And then we have the definition of a one-to-one function. The first word in one-to-one function saying what? A function. What does it mean? This function means the entirety of this definition. This word means the entirety of this sentence. So only for function, we talk about one-to-one function. If it is not a function, we don't even talk about one-to-one function, right? But we have more requirement. We have more requirement, domain. So a function with domain A, domain, whatever is domain, is called one-to-one function if another condition. So one-to-one function has more condition than function. It has more requirement to be qualified for to be one-to-one function. For function, the qualification is what? For any input, exactly one output. For one-to-one function, not only you have to satisfy for any input, you have exactly one output, which is mentioned here. You also have to satisfy one additional condition. Do you guys understand that?
Yes.
And what are these additional conditions?
Two different inputs can't have the same output.
Yeah. Whenever, there's a word whenever. So whenever means that for any two output, for any two input, if the two input are different, and their output must be different as well. You follow me? So whenever imply arbitrariness, there's an arbitrary choices. You look at the domain, right? You look at the domain. Any two output, you have to, this condition has to be satisfied by any two outputs. I'm sorry, this condition has to be satisfied by any two inputs that are different. Okay, so let's look at the two. Let's take this definition. Okay, let's take this definition. We're going to look at the two functions we're talking about. Okay, so our question is the function f of x equals to a one-to-one function. And here are the criteria. Do you follow me? So we're using this definition to judge. We are judging. We're judging, is this function one-to-one? X is the input and the rule. The rule says f of x will always produce 2. Is this function one-to-one?
I don't think so,
Why?
because they all have the same output, which is 2.
That's right. Right? But how do you say it? How do you say it? How do you make it? How do you make a statement? Quoting the definition. How do you say it?
No, because the function given has two or more elements of A, or two or more elements of the function with the same output.
You are all right. Okay, but I'm going to show you a very simple way to make that argument. Okay, I want to show you a very simple way to make an argument. And this way is called a counterexample. Counterexample. If you want to counter someone's statement, what do you do? How do you counter someone's statement? How do you counter a statement, for example, in general? In real life, how do you counter someone? Someone make a general statement, right? Don't we all hate it, general comments, right? Let's say, for example, mom said, "You're always late." What do you say?
You say the opposite. I'm not late.
I say, "Mom, I'm not late today," right? Mom says, you are by the way, I don't do that to my kids though, okay? I'm the model mother. Suppose someone says, "You are always late." How do you counter that statement? I know that statement is very hurtful. What do you say? You just have to give him one example. One day you were not late, right? Yes? How do you counter? Okay, so this question is no small matter, because let's take another situation, right? Suppose in a courtroom. Okay, you are the lawyer, you are the attorney. You are the attorney. You want to discredit a specific witness. Okay, this witness may be harmful for your defendant. And this witness is going to tell the story, and this story is going to be harmful for your defendant. What do you do to discredit this witness?
You prove them wrong.
How do you prove them wrong? There are many ways to prove someone wrong, right? One of the things you can, if you have evidence, you can try to prove that this witness is not credible. Is that right? If this witness is not credible, and then his testimony cannot be used. So if you can focus on proving this witness is not credible, how do you prove someone's not credible?
Evidence.
Evidence about what?
Why their claims are incorrect.
Okay. So you're proving this person is not honest, right?
Yes.
How do you prove someone is not honest?
Like we said, provide evidence of. Wait.
Suppose you're talking about me, okay? How could someone okay, I see some comments on chat, provide correct evidence. I think you guys are all kind of thinking. Suppose that someone want to prove that I am not honest. Okay. How do you prove I'm not honest?
Give examples of times that you've lied.
There's one time I lied. How many times do you need to demonstrate I lied? Once? Do you need evidence that I lied once or twice?
Once.
You only need once, right? If you caught me lie once, and you have evidence, then I will be decided as dishonest. Do you agree with me or not? I might have been, I might have told the truth 10,000 times, but lied only once. And you got me. What is the consequence? I will be judged as dishonest. Yes? Do you agree with me? I tell you the truth. I don't like that, judgment. Only God can forgive me, right? For lying once. But that one time I was caught, I will be judged by the world as being dishonest. So what I'm saying here, when we give counterexample, how many counterexamples do we need to give?
One.
Just one.
Only one.
So is x equals 2 and 1.15.
This example, of course, demonstrates the cruelty of real life, right? Unforgiving in many ways. But it also demonstrated a logical method, a method in logic that's often used in the courtroom, in the court, and in real life. Okay, so how do you counter that this is not a one-to-one? So I'm going to show you. Okay, I'm going to give you one counterexample for x for the input 1 equals to 2, x of 2 equals to 3, x of 1 is not the same as x of 2, but f of 2 is the same as f of 3 equals 2. This is how to give counterexamples in mathematics. Which is, what does this counter? This counters the definition. You don't have to use the same inputs I use here. As you said, there are many more. But you must point out, okay? And here you say whenever x1 is not x2, their output must not be the same. And here I have a pair of input which are not the same, but their output are exactly the same. That's how you counter. in mathematics. You get it? And no other words need to be said. No other words to be said. And what we counter here, we're countering that. Whenever, the opposite of whenever is what? Once. The opposite of not equal is equal. You get it? And this is how you express it. This is how you express it. Okay. Bless you.
Thank you. Sorry about that.
No worries. Okay. So let's look at the other function. Let's look at the other function. Okay. We're still taking the definition. We're still taking this definition and we look at this function. Is it 1-to-1?
Yes.
How can you demonstrate it is 1-to-1?
Every input has its own output.
That's right. You're going to use the wording in the definition. Definition is a very powerful tool. You don't need to create other sentences. You just have to just use the same frame of sentences to make your arguments. Just like if you're a lawyer, right? You say you're going to cite up, precedents and this and that, and, law item number so and so. And you use wording to counter or agree. Okay, how do we demonstrate? Then you say, for any x1 not equals to x2, 1 over x sub 1 is not going to be the same as 1 over x2. Okay, of course, they're in the domain. Sorry, I apologize. Okay. i.e. You need to learn the way I present work. Are you guys with me? That's what you need to learn. Sometimes you say, oh, I understand, but I don't know how to write it down. And these are the examples of how to write it down. Okay, for any, you can also replace it by whenever. If the two numbers are not the same, their reciprocal will not be the same. Everybody will agree with you. So whenever x1 is not the same as x2, and their output will not be the same, sorry, here, will not be the same. So I'm quoting the definition. I'm quoting the definition. I'm quoting the definition in my argument. If you're a lawyer, you're going to quote the law in your arguments, don't you? You study mathematics, you're going to quote the definition in mathematics to make your argument. This is how you learn the language of mathematics. Okay, so now so we did the first two functions. We covered two major concepts. One is a function, the other one is a one-to-one function. So let's move on to page number 8. Page number 8. Page number 8, we have a new function. Okay, number 3, page number 8. And what is this function? I'm sorry, guys. I was just trying to make some adjustment, okay? All right, page number 8. What kind of function is this? Going through this rule, and what comes out? What comes out? What comes out?
The input becomes the output.
That's right. The output is always the same as the input. That's what this function is. Okay, and this is the function you guys have learned before. Y equals to x, right? What it means? It means whatever input you give me, I'm going to just push it out the same number. That's the input output. Everybody should know how to graph this one, right? Can you graph this one? I'm going to leave it for you. Okay, you're going to graph this one, decide whether it's a one-to-one function. That's today's homework. Okay. And you know what to do, right? We have examples. Let's look at the next one. Number 4. I believe everybody knows the graph of this one, right? This is certainly a function. What kind of rule is that? What kind of rule is that? Any input you give me, I'm going to take the input and multiply itself. That's the rule. That is a rule. Domain, range. What's the domain? What's the range?
Is it all real numbers?
That's right. All real numbers. Okay, you can use this notation to indicate domain. And what's the range?
All numbers.
Think again. a number time itself,
All real numbers except a 0.
all real number except 0, you'll get multiple choices.
Oh,
You apply the rule. You apply the rule.
it's anything greater than 0.
You think about any number you can do, you can think of, and you take that number time itself, you follow this rule. What are the consequences of following that rule? Go on.
All real numbers greater than 0.
All real numbers greater than 0.
Greater or equal to 0.
None of this is right. What is the consequence of applying this rule to all the numbers you can think of, including 0, including negative number, including positive number? Think about it.
They'll always be positive.
Always positive. What happened to 0? Can 0 be the input?
Yes.
What's 0 times 0?
0.
All real numbers greater than or equal to 0. The right answer is D. If you give me any other answer, 0, you get 0. Mathematical statement has to be concise. It has to be concise. You can't say, oh, it's about right. It's about 90% right. No, 90% right is wrong. 99% right is wrong. 99% right is wrong. Okay? Got it? So what is the range? Very good effort. Okay? I want you to learn this way to express range.
So Professor, you want our domains to always be in interval notation and then our range in,
Doesn't matter. You can use all real numbers. That's fine.
okay.
Yeah. But for range, I will teach you a lot of different ways of expressing range. But I will tell you what I expect you to be able to know. Okay. For this case, I'm going to give you an alternative. Okay, I'm sure in the past you might have learned, you know, this way, 0 to infinity. But now I want you to know this way. Okay, so I want to also show you. I want you to talk about mathematics. I want you to speak it, and speak it concisely. So this can be done by practice. So I'm going to have one sentence description of domain and the range for the function for this function. Okay. We must say it. We must speak it. We must, you know, write it down. Because this language of mathematics, as simple as the grammar is, it's not easy. You have to think about it. Right? So how do I combine these two sentences into one simple mathematics? It's x squared greater than or equal to 0. That's the one sentence statement. Do you agree with me or not? It covers the domain, which is any real number. It covers the range. Sorry. It covers the range. And you should make it in such a way everybody understand what you're saying. And you need to make sure that statement has no loopholes. Got it? Okay. It's the end of the class. Homework. Homework. Okay. I want you to continue to work on okay. You will work on the function, okay, from page number, let's see. Numbers 6 through 10 to 11. Okay. So these are basically the same idea. You do the graph, you find x-intercept, y-intercept, and then you decide whether they're one-to-one function. Okay, and this week you should expect another quiz, which is about these. Okay, of course, we're going to cover more materials tomorrow. Tomorrow is, we're going to continue on this. Tomorrow we're going to continue on this. If you have any questions, please don't hesitate to ask me, okay? Two important definition, two very important definition. And we learn how to apply, how to use them, okay? And I think I need to let the interpreter go. She might have to go to another class. And if you have any questions, please let me know, okay? So if you have more time, you can work on basics 1. You can work on more pages, okay? At least 1 per week. Yeah, you should expect 2 per week. You should expect 2 quizzes per week, at least 1 per week. Okay, all right, good job. Very good participation. Okay, I cannot say enough, and I cannot praise enough about your participation. It's very, very helpful. It's very, very helpful. And if you have any questions, and I will stay a little bit longer. And actually, I'm going to go into my office hour. Okay, I'm going to go into my office hour right after this. And if you have any questions, please let me know. Okay, I'll put the assignment in the homework page on Canvas, in Canvas. Okay. Thank you, guys. Very good attendance. We have very good attendance today.
Thank you.
Thank you.
Thank you, Professor.
Thank you.
Great day, Professor.
Thank you.
too.
Everybody have a nice
Thank you.
day.
Thank you. I'm looking forward to seeing you tomorrow.
Professor, there was a question in chat. Is there a 15-minute limit on the quizzes?
Yes. Yes.
Okay.
Thank you, Kim.
You bet.
Thank you very much,
See you
Kim.
tomorrow.
I hope
Sure.
I don't. Yeah, okay. Thank you.
Yep, you're fine. Thanks.
Thank you. Appreciate it.
I have one more question.
Okay.
For the function of f of x equals 1 over x, how do you write the range in interval notation?
Which one?
It was f of x equals 1 over x.
The interval notation?
Yeah, how do you write that in interval notation?
The interval notation, if you prefer interval notation, you can do it this way.
Okay.
Okay. You can write it this way. You can write it right here. From negative infinity, comma 0, union 0 to positive infinity.
Got it. Okay.
So this is much easier.
Yeah, it is.
Yeah.
I have a question on that one as well.
Mm-hmm.
How would you write that in a full sentence, like how you did for example number 4?
How do I write interval notation for number 4?
Yeah, like how you did x squared, how you like did the domain and range in one sentence. How would you do it if there was like for 1 over x, like x couldn't equal 0? Like how would you write that?
For here, are you talking about this function?
Mm-hmm.
X is not a 0 equal to 0. That's enough.
Yes. So like how would you write that in the like how you did for example 4? How you said like it's easier to just write it in one sentence for domain and range.
Oh, one sentence. Oh, okay.
Mm-hmm.
Okay, you can do this. Okay. You're referring this function, right?
Mm-hmm.
You
Yeah.
can say 1 over x cannot be 0 for any x not equal to 0. One sentence.
All right, thank you.
Very good question. Any other questions?
I had a question about the first quiz.
Yeah,
Do we take that today?
it's due tonight.
Okay.
Okay, but I'm not going to answer any questions in that quiz until it finishes, until past the due date.
Okay.
Okay, so closely related to the lecture yesterday.
Okay, thank you.
All right. Any other questions, you guys?
So what are the parts that are required? So it's just the graph, the table, and
X-intercept, Y-intercept.
that's it?
And you determine whether it's 1-to-1. Do you see those pages? Those pages has laid out those.
Yeah, I was just making sure.
Yes. Okay. You need to give the domain, range, x-intercept, y-intercept, and sketch the function. Got it?
Yeah, thank you.
Mm-hmm. Any other questions? Okay, I'm going to be heading towards my office hours. And if you have more questions, then please just go there.